Across Britain, workshops and factories are hives of activity, from the high-tech to the handcrafted. Great Britain has a proud history of clockmaking. For a time, we produced the best timepieces in the world. Today, there are only a handful of these master craftsmen left, but Committee of London are dedicated to keeping the tradition alive. The 170-year-old firm is led by Simon Barker.
I'm the managing director of Committee. I'm a member of the family that goes back 5 generations running this business. We offer long case clocks, grandfather clocks. We offer mantle clocks, traditional and contemporary. We offer wall clocks. And we've drawn on this heritage of making fine clocks in this country to create some exceptional timepieces.
And their most exceptional is the £12,000 Navigator. It was designed as a tribute to one of Britain's greatest clockmakers, John Harrison.
He was an extraordinary innovator and made such a contribution to the history of this nation.
300 years ago, accurately navigating at sea was the biggest technical challenge of the day. Cracking it would help countries trade goods, win wars, and build empires. And the key to all that was accurately keeping time. Because knowing the precise time would let navigators calculate a ship's longitude, its position between east and west.
In the 18th century, this was a key technology, and Britain, as a maritime nation, in fact, all maritime nations were searching for this solution.
It was so important that Parliament offered a prize worth nearly £3 million in today's money for whoever could provide a solution. And the man that cracked it was John Harrison and his H1 seafaring clock.
As a result, our navies are the British Navy, the Merchant Navy, and all the exploration and things like this, we had an advantage over other nations. In fact, we produced the best sea charts. And of course, we always stuck the meridian, 0 time, if you like, in Greenwich.
Harrison's original H1 is housed at the Royal Observatory in Greenwich and is still working perfectly after nearly 300 years. Committee's tribute to the H1 includes many of Harrison's technical innovations. Each clock takes over 6 months to complete. The first job is to produce the array of intricate parts.
This is the parts that we manufacture here for the clock. There's quite a number of parts, approximately 170 parts in total that we make for the clock.
They're all milled from solid brass with super accuracy. First up are the front and rear plates that will eventually make a frame to hold all the other parts in place.
The raw material is brass CZ120. It's coated with a plastic sheet over it to protect it when it's delivered to us, to prevent any scratching. We then load it onto the machine. The accuracy we have to work to on these plates is approximately 10 microns, which is, a human hair is 75, so it's quite fine. The process is approximately 30 minutes from start to finish. The manufacture of these is approximately about 16 pieces per day. It's quite a slow process. The most important thing is keeping the quality of no marks, dents, otherwise no one will buy the clock.
Next door, another key component is taking shape.
This is actually the hour wheel, and when the product is finished, the hour hand goes on here. So this is the main centerpiece of the clock itself. So when the teeth are cut, there are 75 teeth on this gear.
The gear's teeth lock the 2 moving parts together. They're used in the clock's mechanism to transmit movement and are cut on a special machine from, where else, but clock-loving Switzerland.
It's quite an old machine. It's a Swiss-made machine. It started off in the 70s with all the watch industries and all that, these machines. So it's a very precision machine, which can last for years and years.
Every one of the 170 parts is then checked for accuracy.
This is a pair of front and rear racks. They're accurate within 2,000 of an inch. Anything which doesn't fall within his scope, there won't be any good to use on the clock.
Of course, none of this high-tech kit was available to Harrison.
extraordinary story of John Harrison is that originally he was a carpenter and he made clocks from wood. But he realised that he had to up his game to become a precision instrument maker to produce a timepiece that would be accurate and operate on sailing ships.
I think he'd approve of today's efforts. After all the metal parts have been machined, checked, and then checked again, they're sent off for electroplating. Electroplating gives each of the pieces a decorative coating just 1 micron thick. First, the parts are dunked in a hot alkaline bath to strip any grease or grime off, before they're submerged in a solution containing, amongst other things, cyanide, and a third containing gold particles. An electrical current is sent through the parts, which bonds the gold particles in the solution onto the surface. After 30 seconds, they're rinsed before they can be snipped off the frame, dried, and then polished, ready for assembly. Painstaking job of putting all these parts together falls to Chris, who thankfully takes it in his stride.
This is the train. We're putting the train in.
His first job is to assemble the interlocking gears called the train. Like a miniature gearbox, they ensure the hour and minute hands move at the right pace.
This is the fusee. And this is the barrel with the mainspring in. That's the going system, the power of the clock.
The clock's power comes from the main spring that's tightly coiled inside the barrel, a bit like a battery full of potential energy. The fusee regulates the release of the energy, keeping it constant.
You're winding it on the fusee, so as you pull the gut onto the fusees, you're in fact winding this mainspring up.
The gut is a thin steel cable that's wrapped around the conical shape of the fusee. The mainspring pulls the gut, which turns the fusee, which is connected to the train, and eventually the clock hands.
It was designed by Leonardo da Vinci years ago. Don't know when. All Old English clocks have this system, and Old English pocket watches have this system as well.
Before the spring can be wound, Chris has to finish the framework.
Right, now I'm going to put the front plate on.
Like a car's chassis, the frame holds everything in place.
Lining up the screws to give it a nice appearance. I'm going to put the escape wheel on. It's the tick-tock of the clock.
As its name suggests, the escape wheel lets the energy held in the spring to, well, escape and drive the gears of the clock.
You put power in and take power out, so keeping it on a constant tick-tock. This is the clock dial, yes, that's it. And there's your seconds disc. Right, now I'm going to put the power onto the fusee. So I lock the escape wheel down.
The fusee is designed to keep the power that's released from the spring even. Otherwise, the clock might tick faster just after winding and slower as the spring unwinds.
When the fusee is full with the line, I've got to put the oomph into the mainspring.
Winding a clock coils up the mainspring, loading it with the energy that keeps the hands moving.
Now I've got to let the line from the fusee go onto the barrel. So I have to take off my train restraint and just let it gently run through my fingers so it layers itself nicely onto the barrel. It's a clock's first breath.
The assembly can take up to 6 hours, which sounds like a lot until you consider Harrison spent years on his first design and a lifetime thereafter perfecting it.
It's not all that easy. I mean, once you get to know it's like anything, it becomes straightforward for you, but it is quite tricky.
Next up, the pendulum balancers are delicately installed.
Oops.
The swing of the balancers locks and unlocks the escape wheel, releasing a set amount of energy from the fusee.
They regulate the clock. They're the heartbeat of the clock, really.
It was this revolutionary part of Harrison's design that allowed his clock to keep time at sea while all the others failed. In the 18th century, pendulum clocks were the most accurate around. Their long, evenly swinging pendulums used the Earth's gravity to keep a clock ticking at a constant rate. But the motion of a ship at sea would make traditional pendulums useless, so Harrison used pairs of balanced pendulums that pivot in the middle, appearing to float.
So I can demonstrate how these are acting as balancers. When the clock is out of motion and you move it, they will not move at any angle. So when they are in motion, the clock will continue to run at any angle. So basically, the pendulum balances are floating so that they're not affected by the motion of the ship.
No matter how stormy the sea, they'll keep swinging at any angle. Thanks to the balancers and other innovations, Harrison's clock kept time to within a fraction of a second per day. A huge technical breakthrough. Back on the factory floor, the clock's nearly ready.
Then the hour wheel goes on. Putting the hands on is sort of the last job. I like to get it all going, seeing everything's all hunky-dory first. And there we are. So now it has to go on test. Fully wind it up. That will go for 8 days, and then you have to wind it up again.
The movements are put on test in these cupboards for 3 weeks, where on a daily basis we note their performance. We'll find there's an error on a daily basis, and to adjust this error out, you make small incremental turns to these rating nuts. To make the clock run faster, you bring them down a small amount, and to make the clock run slower, you bring them up a small amount. This process can take 2 to 3 weeks to bring the clock into time.
Once it's fully calibrated, the clock is paired with a wooden plinth and encased in glass, right on time. As for Harrison, even after proving his design, he had to fight tooth and nail for nearly 40 years to get his prize money from Parliament. But his designs went on to revolutionise navigation at sea, saving countless lives and cementing Britain's position as a global superpower.
It's a very British story because the people from the British Isles are extraordinarily innovative. And this innovation has an extraordinary impact on all our lives.